We're going to share. Okay, so today we're going to start with the chapter 8, designing classes. If I were you, chapter 8, 9, and 12 would be my whole life for next few weeks. You need to understand these chapters very well if you want to know object-oriented design. So we went over some classes in chapter 2 and 3. Now we're going to go deeper of how we're going to design these things. Pardon me? Did somebody have a question? Okay, so what we're going to do in this chapter is how we going to choose appropriate classes for the specific problem. So we're going to go through certain algorithm. I show you how those algorithm is done. So when you want to design your class, you can have some kind of a idea or algorithm. If it's like this, you can do it this way. If it's like this, you're going to do it that way. We can understand the concept of the cohesion, and that's where we're going to spend some time in our design to be sure our classes are done correctly. We're going to be also working on minimizing the dependency and side effects. And we're going to be looking at how to find the data representation of a class. We're going to be talking about static methods and packages toward the end. I put the packages for your learning team assignment. So you're going to be doing packages for this. I am not too concerned about packages for this class, this course, but we're going to do it at least one time so you know how is it done. Some IDEs create packages for you already, so some of you already have it and some it doesn't, but it's good to know how the packages work and what does it do, and eventually you can create your own packages. And we're going to be talking about the unit testing again with the frameworks on it. All right. So let's start with classes. When we talk about the class, we are talking about a single concept. So one single concept, we're going to create, we're going to be thinking about a class. So that can be like a mathematical concept, a point, a rectangular, ellipse, or a real life concept like bank account, cash register, things in that matter. Nida, you have your microphone on. Can you turn it off, please? So we can think about the actors that they have ER or OR at the end. So we can think about it like that. So when we create an object or we are looking at that object, then we can name them better. So if I have an object called random versus an object that's called random number generator, so you can see the generator part of it, that's going to be called as, it's going to be more familiar to be an object. So Java does tend to write more than C++. So if you're coming from C++, you might complain. I did complain, I still complain. That is a lot more typing, but it's going to have more meaningful concepts in there. So that's what we are talking about. We have some utility classes. You have seen it. These utility classes, we do not create an object for it. We just use them as they are. So remember, for every class that you have to create an object for it to use it. The one that you really don't see the word new in front of it is a string, that when you create an object of a string, it happens behind the scene. You don't see that, but other than that, you're always going to have that word new to create an object to use. But the static ones, You don't do that. You don't create the object. You just use the methods that's available to you. So we saw the math as a utility class. We have some thing called program starter. So we have been playing with those things. So that would have a main in it. So we're going to have multiple classes, and then we're going to have one class with a main in it. So each class is going to have its own concept, so I can have more than one class. We talked about the testing those classes. So I might create some testers with main to just test one of my classes. And then I would have the main for my whole program that's going to be handling the starting and finishing up the things that we do. Now, my main is going to create object of my classes. Remember, you need to create an object before you use your class. It also handles your input and output. So one of the things that I want to emphasize, even though we do something sometimes in here, generally you want to take your input and output out of your class. We do not print anything inside the class. The reason for that is we don't know where we're going to use the object of this class. So I might use it in a GUI. I might use it in doing reading and writing to a file. I might use it to read and write to a database. So reading and writing should not be the concern of my class. It's going to be a concern of some other things. Maybe the main would be a good place for it to do it. So I can take my class. Remember, the idea of the object-oriented design is anybody can use my class and put it in anywhere and it's going to work. So we're going to be thinking that way, that the classes are going to be for reusable code and we can insert it in any place and it's going to work. It shouldn't have any dependency to my project. My classes are going to be independent. Another thing that we're going to be focusing on is going to be that the class name should indicate what object of class will do. So when we're naming the class, when we're creating our own class and we're going to name it, it should, when I look at the name, I should be able to say, okay, what is this class is doing? So paycheck program, some of you might think about it as my program, but I'm focusing on class and I'm not going to call it paycheck class. I'm just going to call it paycheck. So paycheck is generally a class that's going to handle the paycheck. This is something important, especially you're coming from CS2. We have to work on this. We have to practice on this, that a single operation or action is not a class. So a single operation example would be, for example, compute paycheck. The computation or the compute is not a class, is just an action and is part of a paycheck class. And we're going to be practicing, especially if you're coming from CS2, to get that concept going. Okay, so I have two self-check that should wake you up or warm you up, however you want to look at it. So I have it in activity somewhere in here. Okay, so I have it as activity 6.2, and I'm going to put you guys in a group of 2. There is only. Thank you. Okay, so let's talk about the methods. So the methods are the action that happens in our classes. So a class should represent one single concept. You're going to hear me say this again and again and again. So when we are looking at a class, it's only going to have one single concept. So it doesn't have multiple concepts in it. Now, how do we communicate with outside world? How does the class communicate with outside world? That is called public interface. So that's the way it communicates with outside world. My house has a door, front door, that is going to interface with outside world. So anybody want to come to my house, they have to come through my front door. Anybody want to talk to me, they have to come through the front door. So the public interface is how we're going to be communicating with outside world. Now, when we're talking about cohesive, that means everything that I have in my method is going to be directly connected to my class. So I cannot say my public interface is my neighbor's door. It has to be connected to my own class. And you'll be surprised at how many times we do that. And especially if we don't do design very well, we start thinking about the program and then we say, oh, I need this, I need that, I need that. Then we start creating method that doesn't belong to my class. So we got to be careful about that, that all the methods are going to be directly connected to our concept of our class. So we can talk about the common goal that everybody is going to have the same goal, and that's what we're talking about. Now, we are looking at this. We have receive a payment. We have a cash register, and then how many concepts do we have here in this one? Are they all in one concept or they are different concepts?
I think they're all different.
Okay, what are the differences?
So the first class is like a cash register, and it holds the values of like the coins, and then the other one is like receiving the money. So just completely different from what the first one's doing.
So are you saying that the cash register job is not to receive the money?
I mean, I treat it as like a separate thing because one is just like values of what could be inside the cash register, if that makes sense.
So you're talking about the balance of your cash register.
Yeah.
So if I have a balance in my cash register, my receiving payment is going to be changing my balance. So they are still talking about the same concept. I'm talking about balance, receiving money, and those kind of things. So the thing that doesn't belong to my cash register is actually the coin. If we're talking about the concept of the coin is not part of the cash register. So my cash register, even though we're talking about the coin, is not the coin is not the cash register. Cash register is not a coin. They are not the same thing. So we have a cash register that's going to hold coins, compute the total, but the value of individual coins is a separate concept. So we have two concepts. We have a concept of the coin. And remember, just because the value of the coin is different doesn't mean it's a different class, it's a different object. So my coin is going to have we can have a value for it and we can have a name for it. So and we can have or get value and the constructors and all those things. That reminds me, there was a discussion in the question area about the constructors. The constructor does not return any value. The constructor has to be void all the time. So I mentioned that over there. And so if I have 10 different coins, or I have 5 different coins, they not necessarily they are different classes, they have the same concept. So the question is, what do they have in common? The coin have a value and have a name. So the dime has a value of 10, the nickel has the value of 5. That is going to be a different object of the same class. Now, my cash register is going to be holding these things, so that's the way it's going to calculate its balance. Or it's going to do the receive payment. So we have to work on this. Again, if you're coming from CS2, you got to work a little more than my other students. I hope that you guys went through this in your 3A if you're coming from there. So we have to have one concept only. And as we go forward, we're going to understand this a little more. We're going to be working on it. We have something called the UML, Unified Modeling Language. We can use Visio from Microsoft, which is available to you as a student for PCC College. And there is another one that is called Draw.io. They're changing the name for Draw.io. So you gotta have a Google Drive. So you gotta start looking at this, and we're gonna be using this. UML. So there are different ones that we can use. Let's choose this one. So this is the way we can create our classes. So we have the class name, we have the fields, that would be my instance variable, and then we can have the methods. In Visio, we would have minus signs for our field, plus sign for our method. This is the way we're going to be using either Draw.io or Visio to design our relationship between the classes. So that's what the UML is. In a visual way, it's going to show us how the classes are connected. We're going to spend more time on this in next chapter when we learn the dependency of the classes to each other. So we can work on that a little more. But for now, to just understand it, the idea of the UML is to show in a picture way how our classes are connected with each other. So these are the symbols that is coming from chapter 12. We're going to talk more about it in next chapter, and then we're going to talk about it in your final project, and we're going to be talking about it in chapter 12. So we have aggregation. That means a class has another class in it. So if my cash register has coins, then we can talk about aggregation. We can talk about dependency, that one is depend to the other one, and that's what it was defined over here. It says cash register is depend on the coin, but it is not a coin or anything in that relation. So cash register cannot operate without the coin, but the coin can be in existence without the cash register. So that's what this is. That's called dependency. Again, we're going to spend some time on this in chapter 12 and possibly chapter 9. And as soon as we start our final project, we're going to be working on these things. So how do we minimizing our dependence? So if I have a lot of classes, depending to a lot of classes, that means I have to be careful about what I do. One might be that I cannot have this class, I cannot have the object of the one without the other one. That means I have to be sure I create the object of one before I create the other one. Two is when I do some stuff, I have to keep eye on the dependency. So in general, we don't want to have too many dependency. So we're going to be removing the dependencies that we don't need. So for example, here we have a print ln, which is in a bank account, we might need this print ln to print something in there. But we can be dependent to the scanner. We can be dependent to printing. So this is something that somebody was asking on the question one. If you are adding numbers to your string, automatically it's going to change to a string. So this is something we talked way early. So the best way of doing these things is the best way to do these things to get less dependency is to basically put our input output outside of our class. So that way I don't have dependency to the input output. So if I put print ln, I am assuming that anybody who's using this class is going to be in front of the computer looking at the monitor. That's not the case. So to reduce dependency from the input output, we just remove it from the class. Questions so far? So they are dependent to the system that are out, and not every computing environment has the system that are out, and we just want to review. All right. Next topic is about accessors and mutators. We already talked about this in chapter 3. So just a review on that one. The mutator is going to change the state of an object. The accessors is just going to do some reporting. So it's just going to give me some value or do something. All right. There are some classes that are immutable. That means we cannot change anything inside of it. Do you remember any class that's immutable? You cannot change the content of it? What was it that you tried to use and then you wanted to modify content of it inside of it and it didn't let you do it? Come on, guys.
A card object?
No, the card you cannot modify. I mean, okay, we can think about it that way. But the most common one was the string. So if you had an object of a string, you could not modify its characters. You had to create a new one and copy it over. So that's one of the one that you have seen. And then you can think about the card object. Do I want to modify things in there or not? So if I don't want to modify stuff like coin, for example. So if I have a coin and I create an object of a coin, which has the name of dime and it has the value of 10 cents, do I want to change these things? So if I have a coin called dime, most likely I'm not going to change either the value or the name of it. And mentioned card, if I create a single card that has a suit and a number, and that card most likely isn't going to be changed. So I'm not going to have a mutator method inside of that card class to change anything. So if I don't have a mutator inside the class, that is an immutable class. That means I cannot modify the things inside of it. So why are we able to safely share? Because we know if I give you my object, you're not allowed to change it. So if I give you a card, as he said, or if I give you a string, you cannot change it. So I am going to be safe by giving you that. If you have mutable methods in there, then there is a chance that they're going to be modifying it. And that is generally what we call the side effect for the class. Okay, so if it's immutable, that means we cannot have any mutators in there. Now, if that's not the case, then we're going to be separating our accessors and mutators. Generally, the mutators are not returning anything. The mutator's job is to modify the content of the class, which is generally the instance variables. And our accessors are the one that's going to return something from my class. So this is most of the time. I'm not saying it's 100% of the time, but that's the goal that we're going to be working on. So if I have a mutators, that means I'm changing the content of my class, my object. Generally, they are void methods. So sometimes we can have a return value. We say that,
What does it mean by informational value? Like, why do they categorize it as information?
So the mutator, okay, so you are asking for to calculate the interest rate or something. So when I do some calculation, when I do some information, so you say, get me tax rate, or you're going to say compute interest. So these are going to return you a value related to what you're asking. Now, if I am going to change the interest rate to the new rate, potentially I'm not returning any rate. I'm just changing the previous one to the new one. That's my mutator. Sometimes I'm going to be returning, let's say, Boolean or a number or something to indicate that this operation went okay. So I'm going to be changing my tax return to a new tax return. But if something is wrong, I'm going to return a value saying that there is something wrong with my method. This is not common, but it is available. So that's what it is. It's not directly connected to what we're doing. It's just some information, like everything went okay, or we had an error. So we're going to return some numbers for our errors in that.
Okay, thank you.
So the second one is talking about that. So when we were doing with the array list, when we call the remove, which is the mutator, it's going to return a true to say that that was successful or not. So even though it's a mutator, it's going to return a Boolean. And that's what we're talking about. So This is an example for that, that if I drink a little bit of the water, I am changing the content of the bottle, the water inside the bottle, and I'm checking for the temperature. So I am modifying it and I am checking the temperature. So these are some exceptional way of doing it. That is not something that we all going to be doing. So the goal is our mutators are not going to return anything. Our accessors are going to return something. Our accessors are not going to change anything inside our class. Our mutator are not going to return anything. So that's in general rule. Are we okay before we move on?
Yes.
Okay, so that generally going to cause some side effect. That means something from outside can modify my data. So if I have a mutators, that means somebody somewhere can call that mutator method and they can modify stuff from my object. So that's generally the side effect of my mutator methods. So this is something, okay, I put down some general style at the bottom of the modules, and I am throwing the links to them once in a while, but it's a good idea to look at them. It's from end of your book. So one of the things that I want to be sure that we understand and we follow, especially if you're coming from CS2, is if I have a parameter in my method, I'm not going to modify my parameters. So whatever I'm passing into as a parameter, I'm not going to modify my parameter. I can create a temporary variable, I can work with it, but I'm not going to modify my variable. Especially you got to think about it, that most of the things that are happening in Java are classes. So most of them are passed by their address. So most of them, you are able to change them inside your method. But the rule of thumb is we don't want to do it. Why don't we want to do it? Because if I pass something to your method, and after your method, I want to use it, I want to be sure that whatever went through this method is going to stay the same after the method. So if I want to modify something, I'm going to have a return value that I can use it to assign it to something else. I'm not going to modify the parameters. That's a general rule that we need to practice. Again, there is a lot of information in this chapter, and I want you guys to do extra reading. You don't understand it, let's talk about it. These are very, very important. It has to stay with you for a long period of time. Any questions so far? So I have this array list coming in. So I have an array list as a parameter. And I don't want to change this array list. So if I am doing any kind of changes in here to this array list, that means after I call this get total balance, my array list has changed. And that can cause some inconsistency inside my program. So somebody somewhere called this method and my array list has changed and I'm not aware of it, that it has been changed. And then I'm going to use it somewhere else and I'm using a change array list. So how do I fix this? I don't want to modify the accounts that's coming into it. How do I do that? How do I fix that issue? Are you guys on the same page with me? Do you understand what I'm talking about? If it's not clear, let's talk about it.
What are we trying to minimize ultimately?
Okay, so the accounts is coming in as array list. The account is coming in as array list. In general, we do not want to change the parameter value. But in here, I have a remove 0, which is removing what? The first element of my account. And because it's in this while loop, it's going to keep changing it. That means the accounts that come in after this method is going to be totally different than what it came in. So how can we guarantee that this accounts, array list accounts, is going to stay the same after this method is done?
We make a temporary copy of the array list using the given copy, or we can manually copy it into a temporary array list using a loop of some sort.
Good. So if we want to modify this, we're going to create a temporary one. And the temporary one, if we need to return it, we can return it. But in this case, we don't need to return it. So we just need to do the sum. That could happen for the ones that you guys were doing in array listing in last assignment, that if you wanted to find the maximum, the customer, the highest, the best customer, whatever it was called, then some of you would remove the best customer to get to the second best customer. So that means that you were modifying your array list. So at that time, you would have lost the first or best customer. So that's the instances that we're going to be careful about. So again, if I have a print statement, that is a side effect because I'm going to be depending to this one. I am not free from input output. So in this case, this class only going to work if I have the user in front of the computer looking at the screen. So I cannot run this class in a program that's going to be run in the middle of the night. So that is the dependency that we generally don't want. So we are not going to be using that print. I like this one. So the side effect of the taxi is spraying the bystanders with the muddy water. So we can have side effects. We want to remove those things. Okay, so we're talking about consistency over here. And when you get your first job after graduation, the company, if you are in the computer science, is going to have you around for about a year before you be a productive person. So they pay you. The going rate right now up north is 140,000. If you are good of you know what you're doing, so they pay you $140,000 to just learn how they do things in their company. Part of that is the consistency that they have in the company. So they would have some way of doing things. So they will pick up some of it from the language. So if they are using Java, they're going to be using some convention that Java is using, and they have some of their own. So we, as a computer scientist, software engineer in there, we're going to learn and we're going to follow what they are telling us to follow, even though we don't like it. And this is the practice for you guys, to listen to your instructor, even what he or she says is not in line of what you like. Because in real life, You're going to be doing things that you might not be in line of what you like. So you have two options. One is comply for what they're doing. Two, find yourself another job and go. You cannot stay in a company and not listen to what they want just because you don't like it. So advice to you, get used to, I'm talking about coding. I'm not talking about if somebody's asking you to go make a coffee and you shouldn't be doing that. But from the coding point of view, you're going to be used to certain ways of doing it. But they will tell you this is the way we're going to do it in this company. And it might be totally different than your previous company or your next company. That's what they want. That's the consistency they want. That's what we're going to be all compliant. We are going to be writing code for other people. We don't write it for ourselves. So we have to comply for what they are asking us to do. So consistency is very, very important. We all going to be doing that, and that's based on the names and parameter. So we're going to be following certain convention of Java for what we're doing. So the picture and the saying is, even though we can do it differently, it's going to feel better. And for us writing code, it's not for doing the project, who cares? It's about the future and about how this code is going to be used in the future. So it's not about me, it's about who's going to be using this code in the future. So we got to have that in mind. And my code, nobody can make sense of it. So I have a job security. That is not a very good thinking, because generally, if they don't fire you, you will have a chain on your ankle. You cannot move up. You cannot even go to vacation sometimes. So, and it's not good for the company. So consistently good, it's something that we want to do. We want to be like that. Now, we're going to go through some algorithms, and I don't have time to go through all of them. We come back and we talk more about it in on Wednesday. We got to start thinking about our final project to start something. We may have two final projects, and I give you a bonus one if you want. So maybe we can talk about the issues that we had with the poker game, because I know some people were complaining, some people just gave up on it, but let me tell you this. My first job out of my master's degree was I was a consultant inside the consulting company. So they would have contract with other companies, and when they ran out of people, they would call us to go there. So they would pick us up, send it to Nike one day, and then they would pick us up and send us to some aerospace place or airline place. So even though you might think that if I stay in certain industry or certain area, I'm going to be more comfortable with that, you got to understand that if you're going to put yourself in a pigeonhole, when that job goes away, which I can guarantee you will go away, then you cannot find any other job. You got to think about that. If you get very, very comfortable with what you're doing, think about it that in few years, that job might not be there anymore. In my father's lifetime, people were getting a job and they would stay there for a lifetime. In my time, with the computer science thing, it was happening. You would have changed your job a few times. For you guys, I would say somewhere around 5 years turnaround. So every 5 years, you're going to get a new job. So you got to be ready for the next job while you're working. So those are the things, some advices. I felt like I'm going to give you some advices today because too much caffeine. So I'm going to give you some algorithm. I want you guys pay attention to these things, have it on the site somewhere. So when you want to create a class, you're going to look at this and say, oh, I'm doing it like this, or I'm doing it like this, I'm doing it like this. So the first one that we're talking about is patterns for object data, keeping a total. So if I have a class that I want to keep a total, what do I need to do? If I want to keep a total, what do I need to do? What is the first thing I need to do?
Declare an integer.
We're going to have an instance variable to have it for our total, okay? So I'm going to create a private double purchase. Now the question is, what methods do we need to help us with this total? So what methods do I need? Now I have this private data. What methods do I need?
Add.
So we need to add, okay, what else?
We need a getter.
Get.
Get what?
Purchase. Get purchase. Yeah. Get
Okay,
purchase amount.
we need to have a way to report it. What else do we need? So I have a total. So I have a way of adding total. I have a way of getting total. There's one more thing left.
Setting.
Setting and the adding, I think it's almost
It's
the same
Oh
thing.
yeah, it's the same thing.
We have to have a method to clear your total. So let's say you have a cash register, you're doing the total for a customer. This customer goes, the next customer comes in, you start the total from 0. Okay, what about if I want to have a counting? So I'm going to be counting certain things. So I need the instance variable for the counting, whatever you want to call it. And then what methods do I need over here? So I'm going to be counting something. So let's say it's a cash register. I want to see how many items do you have. So I'm doing the counting on your items. In this case, yeah, item count. So at the end, I can tell you, you have 10 item, 15 item, or whatever. So I'm going to create an instance variable. What methods do I need? Nobody's going to answer?
I think we still need an add and a getter.
What did it say?
I think we still need a setter and a getter. And
So
then,
we need to add, just like the previous one, and we
Yeah.
need to get, what else?
Clear. I don't know. Yeah, maybe it's clear. I don't think there's any other things. Yeah.
Okay, moving on to the next one. We have another, okay, so we talked about counting, we talked about the total, we're talking about collecting values. So if I want to collect the values, that means my object is going to collect other objects. A good example here is a shopping cart that's going to have other objects. So I'm collecting other objects. So the good way of doing it is what? Using the array list to collect objects. So I can create an array list of the object that I want to collect. Whatever object that I have, I need to create it for that one. So I need the instance variable, but my instance variable is going to have empty. My array list is going to have empty. So I got to be sure that inside of my object, when I create the object, somewhere, somehow, I have the new. If I don't put a new, then I don't have the object of array list. And then when I try to add something to my array list, it's going to have a problem. So remember, every time we have a class, we have to create an object before we use it. So we got to be sure that we have this new somewhere in there. And then we're going to be talking about how we're going to be putting this stuff in there. Of course, we're going to create something for adding, and that would be the dot add. So now I have this add method that I am going to receive the object, whatever object I'm talking about. In this case, is a string, and it can be potentially other objects. So we're going to be adding this. Now I can call this multiple times, and it's going to add it to my array list that I have it in as an instance variable. So the next algorithm is about managing the property of an object. So in this case, I have a student that has a property of a name. So I want to manage this one. So again, different students are not different classes. They are different object of the same class. Now that I have a name and I want to keep track of it as property of this class, so I'm going to have my regular get and set methods to deal with the property. Okay, so one of the things that we have talked about it, and some of you are still not doing it, is when you receive something, when something is coming into your object, and you are going to be setting, in this case, the property of your class, you want to check it to be sure it is a good data. So I'm going to only update my instance variable if the data that comes in is going to be a good data. It doesn't matter where is it coming from, even though I might have checked it somewhere else. If it's coming in through my mutators, I have to check it to be sure it's a good data. So if I have set name and I'm passing in a new name, what is it that I need to check before I set my name to this new name? What can go wrong? What is this new name can be? What can come to me that's wrong? So I might decide that if it is a null or is an empty string, I'm not going to update the name. So in this case, if you give me an empty string, I'm not going to update my name in there. And another thing that I want to emphasize again and again is we are not going to do any printing over here. Remember, we're going to be taking the scanner out of our class. So we're just going to update it. If you want to return something, I can understand it. But we can always check this one outside too. We're going to update it if we have a good, valid data. We are not going to print any error messages over here. How many people wants to talk to me after the class? Because I have a meeting coming up. How many people want to talk to me after the class? Nida?
Me?
That's one. Only one person? Okay, so remember, when I say the class is over, I only have one student to talk to, that is Nida.
Yeah.
If you want to talk to me, tell me right now, because I have to adjust my time. I have a meeting right after this class. Jonathan, did you want to say something?
No, I was acknowledging what you said.
Thank you. Okay. Now we're going to get into a little more into this. So we are having a student class that we are managing the property of it. That can be some other stuff in there beside the name. And then we're going to have some. So we said that for a typical one, we're going to have a getter and setter. That means we have a get function and set function. But there's going to be some instances that we should not have any set method. Can you think of instance that I wouldn't have a set method for some properties I would have for a student?
Their ID.
Good. So if I have an ID, then I shouldn't have any set ID because the ID shouldn't be changed. So certain things, remember, constructor is going to happen only one time while we are building an object. And if that constructor is going to set something for us, not necessarily we're going to have a setter to change it. I might even decide that the name cannot be changed. So if I create a student object with a certain last name, I'm not saying this is a good design, I might think about that you cannot change the last name anymore. So then the question is going to come in, what about if I typed in wrong? You told me your last name and I typed it wrong, or you put it wrong. But that's the idea, that certain data, certain instance variables, we might not have the setters for them. So when we are setting up our methods for setters and getters, we have to think about it, that are we going to be changing this one or not? So in this case, the ID is not going to be changed after the constructor. We might have some classes, again, remember these ones, write it down somewhere so you know which one is it. You don't have to memorize them. When you see them, you can come back to them. So we say, okay, this matches up with this algorithm, with this way of doing the classes. So this one is talking about the state. So we might have different state of, do you guys see the bar for my editing bar? So I just moved it up. What do you see the first thing in my screen on top? What is the first thing on the top you see in my screen right now?
We don't see anything besides the slide that you have.
Yeah, what is the first thing you see on the top?
It says problem solving patterns.
Okay,
for
okay,
algebra.
good. Thank you. So my ribbon doesn't overlap with the reading. Okay, so we're going to be checking the state. So that means if I create an object for certain classes, they might go through some stages. They might be their state might be different in different time or location. So an example here would be about a fish that can be hungry or not hungry. So if it's hungry, it's going to be looking for food. If it's not hungry, it's going to go to sleep. So we're going to keep track of the state, and that the state can change depending to certain thing that happens with this object. So what are the distinct states for the following objects? So for a student,
Be
what do you
grades.
see as a state for the student?
Grades.
Oh, I'm talking about the state of it, not the recording of a grade. So a student can be active or inactive, or the things in that matter. What about the faculty? Same thing can be to do with the faculty. The faculty is inactive, so right now this faculty is not teaching anymore. A person can do what? What state can be a person? What about
Asleep
the
and not
classroom,
asleep.
college? Go ahead.
Asleep and not asleep.
Asleep, not asleep, married, unmarried. Yeah, you can have different states for that. The classroom is a large classroom, a small classroom, or you can have multiple states with some of these things. So in that case, we will create some static variable, because these static variables are going to be shared among all the objects. So the reason we do this, we don't want to use 0, 1, or 2. We want to use not hungry, somewhat hungry, very hungry. So we're going to create these things. So throughout the class, when we're writing per code, we don't say if the state is equal 0, 1, 2. We're going to say if the state is not hungry or very hungry and those kind of things. So we are going to create this public static final. It's called public because not only the objects of the same class can use it, the object of other classes can use these things. It's a static, meaning that if I create 50 objects, they're going to have only one of these. It's final, that means nobody can change it, it's constant, and the data type is int. I will stop over here to have enough time for Nika. I mean, not Nika, Nida. So we have a couple of more things to go over, and be ready to go over some of these things on Wednesday, and take a look at your.
You said Wednesday?
I mean, no, you're not. I don't see you guys Wednesday. Friday.
Friday. Yeah, Friday.
And you guys said the best way to deal with you guys is to have quizzes on a Friday, right? That's the only way I can get you guys involved. Is that true?
We can try it out.
Well, we're going to try that. So we're going to have a quiz on Friday starting at 9:45. And then we can move on. About the things that we did, about your homework, about your lab, mainly about the reading material. Till you guys change it. Okay, so I'm going to stop right here, and I'm going to be talking to Nida in a private room